3.7a, optimization. Here we go.
Guidelines for solving applied minimum and maximum problems. Identify all given quantities and all. Identify all given quantities and all qualities to be determined if possible. Make a sketch.
All right, so we're going to read it. We're going to figure out what it says. All right.
Write a primary equation for the quantity that is to be maximized or minimized. Reduce the primary equation to having a single independent variable. This may involve the use of secondary equations relating to the independent variables of the primary equation.
All right, so kind of like related rates, there's going to be a primary equation. This is what's going to be minimized or maximized. That's how you know what it is. And then there's a secondary equation. That's going to help us substitute back into the primary to then take our derivative. All right, keep going.
Determine the feasible domain of the primary equation. That is, determine the values for which the stated problem makes sense.
All right, so sometimes like we'll get like a negative, and that's like extraneous in our context of our problem. And so keep going.
Determine the desired maximum or minimum values by the calculus.
How do we get a minimum or max?
With the derivative.
We take a what? Derivative, and we set it equal to? Zero. All right, let's keep going.
The product is 185 and the sum is the minimum.
All right, so we're going to find two positive numbers that satisfy that. All right, so whenever you see the word is, think of it as equals. All right, so I don't know what two positive numbers are, so we're going to give them variables. I'm just going to use x, y, because I'm basic. And so product is 185. So how do we say that? X times y is equal to 185. And then it says the sum is a minimum. So what should I write there? X plus y is equal to S for sum. All right. Now, this part is my primary equation because this is what I need to take a minimum of. So eventually I'm going to take a derivative of this one and set it equal to 0. All right. However, what's wrong with it right now? How many variables do I have?
3.
Okay, I technically have 3, but it's in terms of 2 variables, all right? And so I need to put it in terms of 1. And so that's where we're going to use our secondary equation. So which one do you want to solve for?
Y.
Let's solve for y. So we got y is equal to what? 185 over x. So now I'm going to take that and we're going to back substitute it in right there. And so s is now equal to x plus 185 over x. So now my primary equation's in terms of what? One variable. All right. And so now I'm going to take a what?
Derivative.
A derivative. And so how do I notate taking our derivative? ds dx. All right. What's my derivative of x? 1. All right. And so now I need to take the derivative of 185 over x. How do I want to think of this?
185 times x to the negative.
X to the negative first. Exactly. So what's going to come out front? A negative 1. And then I subtract a power. So now it's x to the what? Negative second. And so it's really what? Minus 185 over x squared. And so now we're going to take that and do what? Set equal to 0. And so now I need to solve for x. And so now I have 1 is equal to 185 over x squared when we add them over to the other side. And so now we multiply by x squared. And so now I have x squared is equal to 185. And then we do what? We square root it. So now we'd have x is equal to what? Technically, plus or minus square root 185, isn't it? However, do we want the negative square root? No, because it says what? 2 positive numbers. And so we just want the positive square root 185. All right. However, we have one of the numbers. We need to solve for the other number. And so now we just take this and we back substitute into one that's solved for y. And so when we solve for y now, y would equal what? 185 over square root 185. However, this one simplifies very nicely. What would we do with this? We would rationalize it. And so how would we multiply by what? Square root 185 over square root 185. And so now up top, I'd have 185 square root 185 over what? 185. So what happens to 185s? They cancel out. So we're just left with what? square root 185. So my two positive numbers are square root 185 and square root 185.
A manufacturer wants to design an open box having a square base and a surface area of 108 square inches. As shown in figure 3.53, what dimensions will produce a box with maximum volume?
All right, so we need to come up with two equations, but essentially I'm going to maximize volume. Now, it says it's an open box with a square base. So let's start drawing our little picture. All right, so if we have a square base, I'm going to call my sides x because I'm basic. All right, so I got a nice little basic square box. And then it says it's going to have a height. And so what's my height going to be? Okay, you want to call it y? I'm cool with y. I'm cool with y. All right, so we're going to call it y because that's what Trace wants. And so now we have x and y. All right, and so what is my surface area going to equal, though, eventually? 108. All right, and so that's going to be my secondary equation. But I need to find my primary equation. So my primary equation is what? Volume. So how do I find volume? It's a how many dimensions? 3 dimensions. So what do I do with those 3 dimensions? I do what? I multiply them all together. So what's my volume of this box? X squared times y, because it's x times y. All right. However, we need to get a surface area equation. So surface area, I need to find the area of all the little surfaces that are here. So what's the surface area of my bottom? X squared. And then I need to add up my sides. And so my sides are going to be an area of what? X times y. It's going to be x times y. Well, how many sides am I going to have them the same? I'm going to have 4 of them. So my surface area is x squared plus 4xy. And what is that going to equal? 108. So that's going to be my secondary equation. All right. So now I actually need to solve for either x or y in this one and substitute it into the volume equation before I start taking a derivative and set equals 0. All right. So which one would I actually solve for? The x or the y? I would solve for the y. Why would I actually solve for the y?
It's one place.
It's only one of them. All right. So let's do our little algebra. You guys are really good at it. And so then how do I solve for y? Y would equal what? 108 and then minus x squared and then divide by 4x. So that's what y is equal to. And so now we take that and we do what? We substitute it in our other one, so now it's in terms of one variable. And so now my volume equation is equal to x squared times the quantity, 108, minus x squared over 4x. So I personally don't want to take a derivative of that yet because I'm going to do a product with a quotient rule, and that just sounds disgusting to me. So we're going to do some algebra. All right, you guys are good at it. And so then what are we going to do with this x squared? Distribute this in. And so then we get what? 108 x squared, and then minus x to the fourth all over 4x. All right, and so then I don't want to do this one either because that's going to be a quotient rule, and so what do we need to do? Distribute dividing. And so now we distribute dividing. So now my volume equation is what? 108 over 4 is? 27. Thank you. And then I have x squared over x, which is x, and then minus x cubed over 4. So now our calculus, we just take a what? A derivative. So how do I notate taking our derivative? dv dx. So our dv dx is equal to what? 27, and then minus 3/4 x squared. And I'm going to do what? Set that equal to 0. So there was our calculus. So now I'm setting it equal to 0. So I'm back to my algebra. So now I have 27 is equal to what? 3/4 x squared. So how do I start solving for x squared? I multiply by what? The reciprocal, which is 4/3. So I take this and I'm going to multiply it by 4/3. I personally would take 27 divided by 3 first, which is how much? 9, and then times 4, which is 36. So now I have 36 is equal to x squared. And so then I do what? I square root it. So then I get x is equal to
6.
6. It's technically plus or minus 6.
It can't have negative.
However, why is it not negative 6?
It can't have negative.
Because it can't have a negative dimension. All right. So I have one of my dimensions. However, how many dimensions will I have for my bulks? I will have 3 of them. I will have 3 of them. So what are my dimensions? 1 6 by what? 6. So what are they? Inches. So 6 inches by 6 inches by, how do I get this other one?
Have to use the
I take this and
substitute.
I back substitute it. That one's already solved for y, so I'm going to put it in right there. And so then we'd end up with 108 minus 6 squared, which is 36. 108 minus 36 is 72. 72. And then 4 times 6 is 24. 72 divided by 24 is 3. And so then my dimensions is 6 inches by 6 inches by 3 inches.
Andy has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area?
All right, so Gandhi has to make sure his cows don't escape. He's got a river, and he's going to have sides for his fence, and he needs to figure this out. All right. So it says, what are the dimensions that the field has the largest what? Area. I personally am going to call these y and this an x because it's going vertical. I'm going to call those y, and then horizontal things I'm going to call x. That's just the way I'm going to do it. You can do it however you want. All right. So I'm going to call it that. So what would be my area equation then?
2y or y squared.
X times y. All right.
Y. Oh, it's just length times.
Length times width.
So,
All right. All right. However, I need a secondary equation that's given to me about our perimeter of my fence. And so my perimeter is going to be what?
X plus 2y.
X plus 2y. And I'm going to set that equal to what? 2,400, because that's how much Gandhi has to use for his fencing. All right. And so now I need to use my secondary equation because my primary equation has 2 variables. So which one do you want to solve for? I personally would too. All right. And so now x is equal to what?
2,400 over 2y. Minus 2y.
Minus 2y. All right. And so now I'm going to take that and I'm going to back substitute in right there. And so then I have area is equal to 2,400 minus 2y and then times y. We could take a derivative now. However, I don't want to. And so what would I personally do? Distribute that guy in. All right. And so now I have what? 2,400y minus 2y squared. All right. And so now I'm going to do what? Take a derivative. So how do I notate taking this derivative? dA dy, because now we're in terms of y. And so now what is my derivative? 2,400 minus 4y. All right. And so now after I take my derivative, I'm going to do what? I'm going to set it equal to 0. All right. And so now I'd have 2,400 is equal to 4y. So what does y equal? 600. All right. However, what's being asked for? It is the what again? The dimensions. So one of my sides is 600. And so now in my dimensions, I have 600 feet by, now how do I get my other one? Back substitute. That one's already solved for it, so I'm going to go in right there. And so now I'd have what? 1,200. Good. And so my dimensions is 600 feet by 1,200 feet.
Did you substitute that into the
So that's our dimensions. However, a lot of these problems might say like, what is the largest area? And so when that happens, what would you actually do? It's one more step. You would just do what? You would just multiply these two together. All right. And so that might be something that's on there. And there we go. It's either 6 or 7 problems.